In this video, we're going to look at the difference quotient. Now, this is a supplemental section, and textbook that's included is, in fact, not part of the original textbook because it's a supplement. So we do need this information as part of our curriculum for the students who are going to be moving into calculus. So the differences quotient is actually something you'll see in calculus. Okay, so let me tell you what the difference quotient is. So if we have an f of x, the difference quotient is defined to be f of x plus minus f of x all over h. It's this expression. Now, what we will do is simplify it, but that's all we're going to be able to do for the difference quotient. So let's look at an example of the difference quotient for this specific f of x. F of x equals 6x plus 4. So I'm going to find f of x plus h. So I'm going to start by finding f of x plus h. So that basically means I'm plugging in x plus h everywhere I see x, which is going to be, let's see, I can distribute the 6, right? Sorry, let me show that. Boop. Distributing 6. Okay, so 6x plus 6h plus 4. And that doesn't simplify any further. So according to the difference quotient, I'm going to take f of x plus h, which is this thing I just found right here, this. I'll take that, 6x plus 6h plus 4, and I'm going to subtract f of x, which is 6x plus 4, right? That's f right there. And then I'm going to divide the whole thing by h. Now I could do a little simplifying. Here's what I can do. I can distribute this negative in and then maybe combine some like terms. So let's see, that'll give me 6x plus 6h plus 4 minus 6x minus 4. So what cancels is the 6x's and the 4's. And I'm left with, in the numerator, 6h divided by h, which actually I can do. I'm just going to get 6. So that is how that's going to simplify. It doesn't always simplify that nicely. We might still have x's and h left in our answer, but this particular one, it did simplify that nicely. Let's try a more complicated example. X squared plus 2x. So for this one, I'm going to first find x plus h, which means I'm going to take x plus h and plug it in everywhere I see x. So it's going to happen twice, right? First in the squared and then in timesing it by the 2. Okay, so I need to figure out x plus h squared. That's going to be a FOIL problem, x plus h times x plus h. So I'm going to multiply the x's, multiply the x first. So x times both of those comes out to x squared plus xh. Then distributing the h, I'm going to get hx is the same thing as xh. So here I'm going to write it like that so that they're same looking, plus h squared, because now I'm going to treat these two like terms. So x squared plus 2xh plus h squared. But I'm not done because technically I've been ignoring this, right? So let me address it. So I'm going to distribute the 2 in. Boop. There we go. So I'm going to get 2x plus 2h. I'm just going to keep bringing that down. And there's no combining at this point. That's as simplified as it's going to be. So now I'm going to do the difference quotient, which is I'm going to take this answer here, f of x plus h, and I'm going to subtract f of x. Oops. Give myself a little space here. X squared plus 2xh plus h squared plus 2x plus 2h. Okay, so that's f of x plus h. And I'm going to minus the original function right here. Minus that. So minus, and notice I put it in parentheses because I'm going to have to distribute the negative. And I'm going to divide everything by h. Okay, so let's distribute the negative and combine some like terms. So minus x squared minus 2x, still all over h. Okay, so it looks like, let's see, do I have any space? I do. I can x and the x squared. So here's what I'm left with. 2xh plus h squared plus 2h all over h. Now, I notice in the numerator, all of the terms have an h in common. So I'm going to factor h out. And the reason is I'm going to do some canceling. I'm going to cancel the h in the denominator. In fact, for all of the difference quotients, the h is always going to cancel in the denominator, always. And if you don't cancel the h in the denominator, you probably made a mistake. So let me make a note of that. Note, the h in the denominator will always cancel. And I'm just adding verbally. If it doesn't, you made a mistake. So you have to work it out so that it will, in fact. Okay, so let's try another example where maybe we have to work at getting it to cancel. So let's use the difference quotient for this. Okay, so I'm going to first plug in x plus h. Plugging it into x is actually going to be kind of boring because I can't simplify it. I'm not even going to put parentheses around it because there's nothing to do. So that's f of x plus h. So let's use the difference quotient now. So I'm going to take f of x plus h, that thing. I'm going to minus the original function, which since it's a fraction, I'm not going to put parentheses, all over h. Okay, so as you can see, this is gross. And at the moment, since there's nothing I can really do in the numerator, I can't cancel h. So I'm going to need to do some simplifying. And how I'm going to do that is, since the numerator has two fractions, I'm going to try to combine the two fractions into one fraction. Or another option is, because this is considered a complex fraction, you can multiply everything by the denominators. I'm just going to go ahead and multiply to get the two fractions in the numerator combined. So I'm going to multiply this by x plus 3. I think what I'm going to show you is a skill that's useful to see for calculus. And this one by x plus 3. I'm sorry, x plus h plus 3. Okay, so the first fraction then, I think I gave myself a lot of room. Okay, good. First fraction is x plus 3 all over. I'm going to write that denominator, which is going to have both factors in there. I'm going to also, for a second, I'm going to take and make this minus. I'm going to change that to a -1. That way I don't forget that it's a minus sign. So -1 is going to now be distributed into that. So that's going to become negative x minus h minus 3. And same denominator, x plus 3 times x plus h plus 3. All over h. Okay, so now those two fractions do combine. I can add them together in the numerator. So what I'm going to do then is I'm going to add, let's see, the x and the negative x are actually going to cancel out. Oop. Just too fast for the computer. So those are going to cancel out. Oh, actually the 3's are going to cancel out as well. See that? If I combine those two 3's, they're going to also cancel out. So that's gone. So all I'm left with then is just a negative h over x plus h times x plus h plus 3, all divided by h. Okay, now when we have a division with fractions, that means we'd flip and multiply. So to flip and multiply, here, I'm going to write it out. I'm dividing this all by h. So that's how I'd write it. And then with fractions, you take the reciprocal of the second one and change it to multiplication. So that's, the reciprocal would be 1 over h. And the reason that's useful is because we're multiplying it by h in the denominator, those cancel. There is still a -1 in the numerator. But now in the denominator, we have x plus 3 times x plus h plus 3. And that's the difference quotient. That's the answer. There's nothing more to simplify. The h in the denominator is gone. This h here, oops, highlighter, thank you. That h here became this h here, which became this h here, which ended up canceling. So that h got canceled, and this is the answer for the difference quotient.